In this video, we will learn how to use the paid version of ChatGPT to analyze about 60,000 rows of Minneapolis weather data in 16 separate files. First, we will learn how to combine the data files, and then we'll perform descriptive analysis, data visualization, and linear regression to predict future temperatures. As we all know, ChatGPT can sometimes make up answers. So that we have a source of truth to verify its output, I've also calculated everything in Python. I downloaded the temperature data from the Minnesota Department of Natural Resources website. I will put a link to their website in the description below, as well as the combined file. I will now log into ChatGPT 4 and ask it to combine these files into one. I will upload 10 files at one time because that is the limit for combining files. Now I will download the new file that is the combined 10 files. I will then upload that with the other 6 files and again ask ChatGPT to combine them into one. Now I have all of the weather data here in one CSV file. Let's go back into ChatGPT 4 and start analyzing this data. Let's add our combined file back into ChatGPT and ask it, please describe this data. How many columns and rows? What is the first date and the last date? Now let's ask ChatGPT to perform descriptive statistics on the maximum temperature, the minimum temperature, the precipitation, snow, and snow depth. This is some good information, but I was expecting something a little bit more statistical. So let's be more prescriptive in our instructions. Please calculate the mean, median, and mode for each of these: maximum temperature, minimum temperature, precipitation, snow, and snow depth. Now, let's compare our ChatGPT answers, which are copied here into Excel, to our source of truth, which is calculated in Excel. And we can see that all of these numbers match the Excel calculations. Therefore, ChatGPT performed the analysis correctly. Now, let's go back into ChatGPT and ask it to create some visuals for our main variables. I noticed that in our data in the late 1800s, they were sometimes only recording data once a week. So let's focus on a more complete data set. Let's ask ChatGPT to focus on January 1st, 1900 through the end of 2023. We now have 5 graphs about our variables. While they're really good, they're hard to read. So let's see if we can make some better displays of this data. Great. We now have graphs of our variables, but they are a little hard to see. So let's be a little bit more prescriptive with our language and make some new graphs. Okay, for our new visualization, I'm going to ask ChatGPT to calculate the average high temperature by decade and the average low temperature by decade for our preferred date range and output it in a table. You'll notice I've had to restart ChatGPT again. Sometimes ChatGPT just gets a little tired and you have to restart anew. Each time you'll have to re-add the data set. Now we have this new data table. Our goal is to graph it. I could have just asked ChatGPT to graph it, but I wanted to be able to see the values too, and that's why we did the previous step. Now we're just going to ask it to graph this and have red be for used for the high temperature and blue for the low. We can see in this visualization that both the high and low average temperatures by decade have been increasing throughout the 20th century. It doesn't surprise me, as we all know about the effects of climate change. And if we go back to our data table, we can see that the average high and the average low temperature both increased about 4 degrees throughout the 20th and early 21st century. Now, let's look a little deeper at the relationship between these variables. So we'll ask ChatGPT to explore the relationship between the variables and we'll list them using scatter plots. Here we get some nice visualizations of the data, and ChatGPT also explains what this information means. Now, let's continue our analysis by asking ChatGPT to use some correlation matrices. Here is our output of the correlation matrix of our weather variables. If previously you've only worked with data in Excel, you might not be familiar with a view like this because this is data science. And ChatGPT is helping us do some data science analysis, but also ChatGPT explains it for us. And so we can understand that through the visualization that we just looked at. For example, here, snow and snow depth are positively correlated, which makes sense because deeper snow would occur with greater snow amounts. If we had some additional questions, because maybe we didn't completely understand this, with a conversational interface, we could ask ChatGPT some further questions. So let's ask ChatGPT to explain this output to me as if I were a high schooler. Okay, this has to be one of my most favorite data science explanations of all time. Temperature talks. Maximum and minimum temperatures are like best friends. They almost always show up together. If it's a hot during the day, the maximum temperature, it's easily like to be super cold at night, low temperature, and vice versa. Rain checks seem to be doing its own thing. It doesn't care much about how hot or cold it is. That's why the numbers between the rain and temperatures are close to zero. It rains when it wants to rain. ChatGPT can help you explain things at different levels. I just chose to use it as if we were in high school for some fun. Let's do one more analysis before we move on to predicting future temperatures. Let's ask ChatGPT one final question about this very complex data that it just analyzed. As a climate data scientist analyzing this information, how would you explain the implications of this data for the Minneapolis community? Now let's do our final calculation. Let's have ChatGPT predict the average high and low temperatures by decade to 2100, and we'll ask it to graph the historical and the predicted data. So, from our analysis, what we have learned is that Minneapolis is going to get hotter. Its average high temperature and its average low temperatures are going to increase based on this projection. And ChatGPT tells us right here that Minneapolis could experience significantly warmer temperatures by 2100, underlying the importance of understanding and potentially mitigating the factors contributing to global warming. Let's ask one final question. Based on these predictions, what impact could there be on precipitation, snow, and snow depth? Let's have ChatGPT explain its answer to us.
The predictions indicating warmer temperatures through the end of the 21st century could have several impacts on precipitation, snow, and snow depth, especially in a region like Minneapolis, which experiences distinct seasons. Here's how these elements might be affected. Precipitation. Shifts in patterns. Warmer temperatures can lead to increased evaporation rates, potentially altering precipitation patterns. While some areas might experience increased rainfall due to more moisture in the air, others could face drought conditions. Intensity and frequency. The intensity and frequency of precipitation events, including heavy rainfall, might increase. Warmer air can hold more water vapor, which can lead to more intense precipitation events when it does rain. Snow. Decreased snowfall. Higher temperatures can lead to a decrease in snowfall as more precipitation falls as rain rather than snow. This is particularly likely during the shoulder seasons, late autumn and early spring. Shortened snow seasons. The duration of the snow season might shorten, with snowfall starting later in the year and melting earlier in the spring due to higher overall temperatures. Snow depth. Reduced snow depth. Alongside decreased snowfall, higher temperatures can lead to reduced snow depth. Snow that does fall is more likely to melt faster, particularly during midwinter thaws that may become more common. Impacts on permafrost and glacial ice. In regions where permafrost or glacial ice is present, warmer temperatures can lead to thawing, affecting snow depth and the overall landscape. Broader impacts. Water resources. Changes in snowfall and snow depth have implications for water resources. In many regions, snowpack acts as a critical reservoir, releasing water slowly as it melts. Reduced snowpack can lead to water shortages during the drier months. Ecosystems. Ecosystems adapted to stable snow conditions may be disrupted, affecting plant and animal species that rely on snow cover for insulation, hydration, and habitat. Human activities. Activities such as skiing, snowboarding, and other winter sports could be impacted alongside increased challenges for communities that rely on snow for water supply or face increased risk of flood due to more rapid snow melt. The extent of these impacts will depend on the magnitude of temperature increases and how they interact with other climatic factors. Adaptation and mitigation efforts can help manage some of these impacts, particularly those related to water resource management and ecosystem support.
Thank you for watching this video. Please remember to like, comment, and share this video and subscribe to this channel for more content like this. Please let me know below in the comments what you'd like to see in a future video. Thank you.